Good morning to one and all present here. Myself, I am Arun Kumar, Assistant Professor in the Department of Mechanical Engineering. I am going to present the subject title Introduction to Mechanical Engineering, and for which falls under semester 1 and year also semester 1. The subject code is ME25303 under the regulation 2025. Now let's move on to the subject's course outcomes. This subject, Introduction to Mechanical Engineering, it purely explains the basics, fundamental concepts, and what are all the fundamentals which is involved in each and every fields of mechanical engineering, such as strength of materials, thermodynamics, and refrigeration. So it covers all. It gives some basics, fundamentals, and constructive fundamental steps for the outcomes, and it also identifies the common manufacturing process for engineering applications. So this is the contents which covers the unit 1, 2, 3, 4, 5. The unit 1 covers the history and evolution of mechanical engineering. That's how the mechanical engineering gone, and starting from the old age to current scenario, how the mechanical engineering step by step it just developed. And it also tells the scopes, roles, and interdisciplinary nature of mechanical engineering, such as force, what is called force, the basics concepts like motion, work, energy, power, and basics standard international units, and also the unit conversions. It speaks of the unit 1 and unit 2, and also it also covers the ethics and professionalism. Also, it involves, that is, basics, ethics, practices for professionalism in mechanical engineering. And the second unit falls with strength of materials. It explains what is strength of materials. That is, of course, the topic is mechanics of materials. It is a strength of materials. It speaks what is strain, what is stress, and what are the types of stress. Some basics concepts like stress strain relationships and bulk modelers, uh, and that some concepts, basics, fundamentals like volumetric stress, volumetric strain, and what is the mechanical properties of materials such as plasticity, ductility, and the materials behaviors like that. And also it deals with actual loading, bending, and what is torsion, and simple structural concepts. And the unit 3 falls under energy interaction, that is the thermodynamics comes under here, and basics of thermal engineering, which deals with heat transfer, modes of heat transfer, what is engines, HVAC, that is heating, ventilation, and cooling, and also thermodynamic cycles. And the unit 5 is purely the manufacturing process, starting from gears, machine elements like gears, bearings, shafts, and also computer numerical control machines. And also it speaks additive manufacturing and smart manufacturing, that is 3D printing. It's called as 3D printing, and currently it is the current manufacturing process is current, the emerging technology is additive manufacturing. Now we shall move on to unit 3, that is the energy interactions. It deals with, it is purely the thermodynamics concepts and thermal engineering. We will be dealing what is called a system, what is called the energy transfer, and the modes of heat transfer like conduction, convection, and radiation, and the working principle of heat engines, and what is a heat engine, and what is a refrigeration, and what is heating, ventilation, and cooling systems, and the demonstration of internal combustion engines, and refrigeration, working of air conditioning, and also the thermodynamic cycles. So what is called a system? The system is defined as the quantity of matter or region in space chosen for study. Uh, that is, closed system, there are two types of system. This one is closed system and another is open system. The closed system means no mass transfer takes place and energy transfer is possible. For example, gas and a piston. But in an open system, both mass and energy transfer takes place. For example, turbine and compressor. So this is the pictorial representation which gives some clear-cut idea of the types of the thermal system. One is closed system, open system, and isolated system. In a closed system, we can see that the energy getting inwards and the energy leaves out. So it is the surroundings we can see here, which is system and which is surroundings. So this the system boundaries is there. And for open system, You can see that how the energy getting inward and energy getting outward, the mass flow getting in and mass is getting out, and on the isolated system no energy transfer takes place and no mass transfer takes place. The best example for an open system is an open cup and saucer in which the heat transfer and mass transfer takes place. For a closed system, when we close the boundaries, so in a cup and saucer, there is no mass transfer takes place. For an isolated system in a thermal flask in which no heat transfer, no mass transfer takes place. So we can give a simple definition for open system, in which the open system can transfer both energy and matter across its boundaries to its surroundings. For example, when a pot is boiling water, it means the living organisms are examples of open system because they exchange heat, water vapor and other matters with the environment. For a closed system, we can give the definition like it can exchange energy, that is in the form of heat and work, with surroundings, but it cannot exchange matter. Example, a sealed radiator or sealed container of a gas are good examples of closed system because mass is kept constant, but heat can be transferred. But in case of isolated system, it is completely cut off with surroundings, neither energy nor matter can exchange. A perfect sealed, that is thermoflask, which I said, it is a theoretical example of isolated system, maintaining constant internal temperature and content over time. So now we falls under that's the three modes of heat. How heat is transferred. Heat is transferred by three ways, that is conduction, convection and radiation. It's called as three modes of heat transfer. In conduction, in simple words, it's a solid to solid contact, that is the energy transferred by direct contact, which can occur with one object and continues until the object temperatures are equal. Convection, in simple words, solid plus liquid medium. It is one of the mode of heat transfer. Radiation is an electromagnetic wave phenomenon. It means, for example, the best example, the sun rays reaching our planet Earth. Radiation means it's an electromagnetic wave phenomena such as microwaves, infrared radiations, and all objects radiate energy, which can transfer energy through empty space. Now we come under heat engine. So before going to this topic heat engine, we should know the law of conservation of energy. That is, energy can either be created or be destroyed, but it can be transferred from one form into another form. So what does a heat engine mean? Heat engine is a device which converts heat energy into useful mechanical work is obtained. But the energy is transferred initially first. The chemical form of fuel is in the form of chemical energy, which is converted into heat energy, and the heat energy is converted into some useful mechanical energy. That is, it receives heat from a high temperature source and converts parts of the heat into work output. It rejects all the heat energy cannot be converted into some useful amount of work. Some part will be rejected as heat. So that is speaks with the thermodynamics first law. That is Q is equal to W plus D. That is the net work transfer equal to net heat transfer. So the types of engines, as there are two types of engines, internal combustion engines and external combustion engines. Generally, what is a combustion engine? That is, the combustion process takes place, there is some kind of heat is involved is there. And internal combustion is the combustion process takes place internally inside the cylinder, is called internal combustion engine. And in external combustion, the combustion process takes place externally. That is, for example, gas turbines, and we can see the old locomotive engine, steam engine. It means the coal is burned and the boiler gets heat is generated, steam is generated, and the steam is converted to some useful mechanical work. That is, the rotational motion is obtained by kind of mechanisms like piston, cylinder, connecting rod, crankshaft, which is connected to the wheel, and we can get the movement. So this is the somewhat the external combustion engine best example, and also gas turbines. So when we comes under engines, we speak about the basic classification of engines, such as two-stroke engines and four-stroke engines. So what is called two-stroke engine? For a two-stroke engine, here we can say the simple definition. In two-stroke engine, there is a power for each revolutions of the crank. That is, the suction stroke, compression stroke, power stroke, exhaust stroke completes in one revolution. So that's why we get two-stroke engines. The power is more, we can say, but there is impartial combustion. That's why we get the oil droplets getting settled over in the muffler. but the combustion process takes place. But we can say the pickup is somewhat, when compared to four-stroke, is more. That is due to its uh, all the cycles is completed in one revolutions of the crank. That is suction, compression, power, exhaust. But in case of four-stroke engines, there is a power for each two revolutions of the crank. That is suction stroke, compression stroke, power stroke, exhaust stroke completes after two revolutions of the crank. So the parts for two-stroke engines is some different important differences. Is you get inlet port and exhaust port and transfer port is there in two-stroke engines. But in case of four-stroke engines, inlet valve, exhaust valve is there. There is the main difference. So for a two-stroke engine, that is the definition. The two-stroke engine completes one power cycle in two strokes. That is upward stroke and downward stroke we will call it. That is, we can also say that for each revolution of the crank, there is a power. The main parts are the piston, cylinder, crankshaft, spark plug, inlet port, exhaust port, and crankcase. So these are the main parts: cylinder, piston, crankshaft, inlet valve, exhaust valve, and spark plug for petrol engine. So what happens in inlet stroke? Intake stroke, that is the piston moves downwards and the inlet valve or intake valve opens. The air plus fuel mixture enters inside the cylinder. And in the compression stroke, the piston moves from upward, that is bottom dead center to top dead center. That is both inlet valves and exhaust valves remains closed and the air plus fuel mixture is compressed. And power stroke, we get the combustion process is attained, that is the spark is generated by the means of spark plug. Some useful mechanical work is obtained in power stroke. In the exhaust stroke, the exhaust gases leaves outside the cylinder through this exhaust valve. During the time, the inlet valve remains in closed condition. So when we talk about four-stroke diesel engines working, that is in four-stroke diesel engines, only air alone is drawn inside the cylinder. So during the time, the exhaust valve remains closed and the air is compressed at a higher temperature, and fuel injector is used for combustion purpose, fuel injection purpose. And when the piston reaches the top dead center, the fuel is injected, which makes the pressure, temperature increases, and the combustion, the thrust is formed. So the flame is generated, which makes the piston to move downwards. So we get a useful mechanical work, and the burnt gases leaves outside the cylinder through the exhaust valve. During the time, inlet valve remains in closed condition. The opening and closing of both inlet valve and exhaust valve is done with the timing gear mechanisms. And this is what the definitions and explaining of the two-stroke and four-stroke engines. Thank you.